Okay, so in this data set, we have wage, industry, occupation, and so on. And the idea here is to know which one of these variables could increase the wage. So if we're looking at predictive statistics or regression, we're going to try to understand, for example, if I'm in a specific industry, could that increase my wage? If I am a certain age or I work in the union, could that increase my age? And then specifically the question in the book asks for age, union, education, gender, and experience. So I included all of those as independent variables, which we'll put in the X range for our regression analysis. And then our dependent variable is wage. That's that desired outcome that we want. So that will go into the Y range. Now for correlation, we don't need to even be concerned with row 1. But for the rest, for regression, we will. So let's first start, though, with correlation, because I want to look at everything in this data set to see if any of them are even related to one another. So go to data in your toolbar, go to data analysis and correlation. In this, we will include the name of each column and all of the data. And we want to save labels in first row and then hit OK. So now you get this table and you can make this a little bit bigger. You can also format these numbers a little bit more so that they're not difficult to read. To me, I think it's easier if we just put 2 numbers after each decimal point. I went ahead and did this and put it in our correlation table here, as well as I went through to figure out which ones actually correlate with each other. So if you remember our basic key here, if we have 0.00, there is absolutely no relationship. And if we go up to 0.30, there's a low relationship. Moderate relationships are 0.30 to 0.50, and high relationships are 0.5 or above. In this case, we didn't have anything that was a high relationship, but we did have several moderates. So in this case, if we look at wage and we try to understand wage and education, yes, there is a relationship between wage and education. Now gender, which this was originally set to female, so I'll just put that back here. But we'll say female is negatively correlated with wage. So in other words, women make less money than men, but there is a relationship to that. So as far as wage is concerned, the correlation table shows education and gender as 2 predictive variables. For industry, we see that occupation and industry are related, which that totally makes sense. If I'm a teacher, I'm probably working in the education industry. So that makes sense. None of these were related whatsoever. Now, marriage, what I see here is that based on our age, we can have a predictive variable of marriage, which makes sense too. If I'm younger, maybe 19, 20 years old, maybe I'm not married yet. But if I'm older, then there's a more likelihood that I'll be married. And experience, which also makes more sense because that correlates more with age, and you see that here, experience and age go together. So age, experience, and marriage, those 3 are all dancing around the same campfire. Then we have education and experience, which also makes more sense. Now it's a negative relationship. So these negative signs in front of the numbers don't mean negative in the fact of it's good or bad. It means that there's an inverse relationship. So in other words, the more education we have, the less experience, or vice versa. The more experience we have, the less education, which makes sense too, because for many people, they'll go to college right after high school, and those years while in college, they've lost the opportunity to work. Or vice versa. If they start working right after college, right after high school, then they have lost an opportunity for education. So that's an inverse relationship in that way. Now, this tells us quite a bit of information as far as wage, because that's really the one that we're concerned with for our discussion post this week is, can we predict a higher wage based on education? Can we predict a higher wage based on gender? And then if we go back here, the question also asks you about if they're in a union, if they have more experience. So age, union, education, gender, and experience are the ones that we'll include in our regression table. However, typically, if they're not highly correlated, then we may not see much happening in the regression table. But just so you know. Okay. Now, you can pop in here, and what I did was a pivot table, just because I love pivot tables. So if you go back to your data set and you hit Insert Pivot Table, and you look at everything, then you can bring in, let's bring in wage, let's bring in education and gender. So it always pops up here in the values section, but we don't really want to see that. Actually, I want to pop that over here, and we'll look at age. Let's actually do one at a time. So age, and I want to see, instead of years of experience, let's make that average. Here we go. And we'll do an average wage too. Let's bring that over here. Let's do an average wage. So in this case, we're seeing, let's see, let's make this a $sign. Okay, so this is just basically telling you that on our data set, we have an average number of years of experience of 20.38 years and an average wage of $30,833.46. It doesn't mean that those two are related, that you're going to make $30,000 when you work 20 years. These are separate. So the good part about the regression table is that they put those two together. Now, I did run a different pivot table here, and you'll see I put education over here on the left, and I put the average of wage on the right. And I thought this was an interesting table where we could see 4 years of education, the average wage was about almost 20,000, where if you have 18 years of education, then you're looking more at 50,000, almost 51,000. So it kind of adds value to the idea that the more education you have, the more money that you'll make. You see a big jump right here between 14 years and 15 years. But interestingly, you also see one here at 9 years. So you could have outliers in the data. Perhaps you have somebody that made a ton of money that only had 9 years of education, but it just depends. Okay, so just kind of in summary with the pivot tables, you do get some interesting information, but it's not consistent enough to make predictions. And that's where the regression table comes in handy. So if we go into wages, again, to your data set, and you look at, and this is where this new row that I added comes in handy. You go to data, data analysis, regression, and in your Y variable, that's here I have it labeled, but we want to start with the title of the column and go down. And then in your X range, that's all of this right here. And you hit OK. Now I've got labels. Make sure you have the labels there, and then hit OK. All right. Now with this, again, we get a lot of information. Went through this a little bit more in detail with a previous video, but the ones that we're interested in are R-square and R-square adjusted. And this time we have more than one independent variable. So we're going to be more interested in this Y adjusted R-square, which tells us that about 33% of the variability in wage or income is found in, and we could say it's found in age, union, education, gender, and experience. So in this model, in other words, in this model. Now what we do see though, if we go down here to the p-values, we see something pretty interesting. These two, the p-values are non-existent. So we don't even want these in here anymore. We want to get rid of them. And what we can do is rerun our regression table. So that's what we'll do. We'll go back to wages. We'll come up here, and that's why I highlighted these two, because we don't want these in the table anymore. Now what we'll do is go back to data, data analysis, regression, and instead of all of those, we'll just put education, gender, and experience in our table. Okay, now we get a brand new table. And if we take a look at this information, now we're still seeing about 33% of variability of wage or income is based on education, gender, and experience. Okay. Then, like I said, we want to go down here to our p-value. Now you're going to see a little bit of a different looking p-value this time, and I'll explain how this works. This p-value, don't get fooled that it looks like 1.44. It has this E, which basically means we drop the number back 7 points. In this case, it says 0.7. So we want to do 1, 2, 3, 4, 5, 6. And at the 6th one, we're going to say 1, 4, 4, 5, 5, 7. And there's a period in front of that. So in that case, see how that works? In that case, this number is extremely significant, right? It's basically 0.00. So it is extremely significant. So I'm going to put that as 0.00 for the sake of it looking good for our table. And then these are also 0.00. So we have a very significant model now at this point. So education, gender, and experience. What we want to know is, okay, this is all fine and good. Looks like these three variables can predict wage quite significantly. They can predict wage, but what does this mean? So if I go over here to my regression model 2, I went ahead and gave the information in written format. So our baseline, or the intercept, also known as a constant, is right here at $12,227.69. So assuming that's your wage, this tells us that for each year of education, we can increase that wage by $3,160.29. So let's say we have 1 year of education, 2, 3, 4, 5, 6, 7, 8. And we start at $12,227.69. We're going to add to that every year $3,160.29. So we're going to do equals that plus this. So each year it will add, and an easy way to do that is to just do the mathematical formula this way. So each year I'm going to do equals the previous year's salary plus the new amount. The previous year's salary plus the new amount. And then once you have that in here, you can drag it down as your formula. And we could go on for years and years and years with this now and see how far we could go based on our education. Okay? And that didn't carry because this didn't carry. So there we go. And that would be your income that we could predict based on years of education. So income based on years of education. And this is a prediction. Now, the next one is gender. So here we see that females can actually subtract so much from their wage each year. So let's copy this so it will save. do a paste special values, and that will save those as numbers now instead of formulas, because now I want to use this for my 11,149.29 that we're going to deduct just because of gender. Oh, let's get this in here. Okay, that didn't work at all. Now we want to carry that down like that. Okay, so now it's saying that based off of this information, we're actually going to take this number and let me roll this up a little bit more. Just subtract. So subtract each year. Okay. So unfortunately, then you see quite a discrepancy in early years because we don't have much to play with. And here in later years, there's still a discrepancy. It's not as easy to recognize whether I make 57,000 or 69,000. You know, it's the same dollar amount, 11,149.29, but it is a little bit more palatable in later years. So that's our prediction based on gender. So let's copy, paste special, and values to hold that there as a number. And we'll do that income based on gender. Okay. Then we want to do income based on experience. So 396.02. All right. And I should say that this is, let's say we have both men and women going to get their education. Then the men would make this much and the women would make this much. Now with experience, we're going to do this a little bit different. So income based on experience, what we'll do is just take our constant number, which is the 12,279. And for each year, we're going to add that plus our 396.02. And so each year we just take the previous year's number and add a little bit more for their experience. And we'll carry that down. Okay, so we can clearly see that if you have more education, we predict that you're going to make more money. Unfortunately, females make less money than men in general. And then if we look at it based on experience only, we can see that you're going to make some extra money each year, but it's just not that much. It's about $400 a year. Okay, so that should take care of it for this week's discussion.